Hello and welcome to a video that is in fact a video relating to Persevere and Motivate, but isn't exactly about Persevere and Motivate. This software is taking a different turn because of a recent sort of, not quite agreement, but we will get there eventually, with a friend of mine who is a web designer. He's very interested in helping build this, provide services within the area that we are in. And I've got obviously my Persevere and Motivate idea that we may be able to put into the services in some way, shape or form. This video, on the other hand, however, is not going to be, in fact, a development series of Persevere and Motivate. Instead, it will be a video regarding a library that I started development just recently. And the main aim of this library is to simplify the database management process on the client and server side. What I will in fact be doing is showing you what we have to offer currently. So over here we've got two files. We've got data, this folder here, and we've got two files here, test data and user. So inside test data we've got 4 fields. It's basically what these are called, fields. One of them is ID. This is an option. Anything prefixed with colon is an option. Inside of these speech marks is the name of the field, and anything prefixed with the anything prefixed with the at is the identifier or the type of the field it is. So in this case, it's this one's here as a text field. That will be interpreted by this parser as a string. This checkbox here would be interpreted as a boolean, etc. Right. We've also got this option here, the key value pair, form ID is equal to title. Eventually what I'd like to do is start creating a function, which is what I'm going to show you in this video. We will be touching on macros in this video, and hopefully you might see how the Haxe macro functionality works. So this is basically a form ID, and it's equal to description. Now, when the parser interprets this, it's going to firstly take the file name, which is test data, and then it's going to apply an underscore followed by the actual key name here, form ID. And then what it would then do is, inside of our main, which is where we've got our build parser.build, we would then generate a function, a private static function somewhere in this main class here, where we can access it to actually operate on these fields. So it may be the case that we want to actually get the data from those fields from HTML and then post it to the server, for example. And here we've got a request class that has a few static functions here. Let's say get, for example. So if we want to get data from the server, like say in this context, we want to get this a certain ID for test data, we would get that using this request get function here. With this URL, we would get back the result. We would then JSONify it. That's not quite a word, but you know, we would convert it into a JSON object anyway. And we would then use the type def that's generated by the parser. Not in this context, it would actually be in the initialization context, which is why we also have this here. So, just to test, I want to show you something. So, we've got ourselves a T user, okay? So T user is again what's generated by this macro here. tuser, it's prefixed with T because it basically shows us and identifies that it is in fact a type def. So we can say tuser here. All of the fields that is generated is optional. So this would be optional, this would be optional, and this would be optional. It just makes it easier for us to construct anything like this in the future. And then we can say, you know, autocomplete isn't quite working because of the structure of the folders here. Sometimes it works, sometimes it doesn't. It's a bit weird like that. But we can do this. Let's say, you know, we've got our username. Obviously, we wouldn't technically do this in practice for security reasons. But if we build that, it builds successfully. This is our main.js. It generated this code. Obviously, as you can see, there's actually no type definition here. Main reason being is because JavaScript, the way that Haxe generates it is it generates type defs inline, which means that it won't actually create a data structure for it. It will just create an anonymous structure, which is what technically a type def actually is. It is in fact an anonymous structure, and where target languages support anonymous structures, that's what Haxe would do. It would just generate an anonymous structure, like in this context. In other languages that don't support type def, or should I say anonymous structures, it would in fact obviously declare a structure in some way, shape or form. It ultimately just depends on what language you're targeting. Dynamic languages such as this one, yes. Static languages like C or C++, not so much. So let's go back to here, and we're going to, let's say, up the ante. So we know that works, that's great. That's just some proof to show that our macro system is working. So we now want to go back into this parser, and I want to improve this. Now I've got two different functions here, one for build types and the other for build. You can actually see the difference. One of them is returning a macro and the other isn't. Reason being is because an initialization macro doesn't need to return a macro, because we're just defining types in this context. We're not actually generating code as such. We're defining types and then we're adding it into the code, and the Haxe compiler will sort of make an assumption, I suppose, as to where to put it. So it, in theory, exists in terms of where it is in the compiler, but it doesn't physically exist on our file system. So when we generate this, for example, this type def here, it's building it. Let me show you. It's building it in the package called shared. Now we do have a shared folder. I don't think it would really make a difference if we had that shared folder or not. In fact, I don't think we really need it, thinking about it. So I could probably just delete this folder entirely. Yeah, I'll just delete it. And I think what we will find is it will just work out of the box. Main reason being is because it's not actually physically generating files. It's actually it's creating the type definition within compiler context, and it doesn't need a physical presence, I suppose you could say, which is good. So it just goes to show the power that the Haxe macro system can offer us. So going back up here, obviously we've got this build server function here. We wouldn't actually use that in client context, which is where we are at the moment. We're in the client context. When we come to doing the server, we would actually, use this function here, but we're not going to do that for now. So I'm just going to get rid of that. So we've got our build types. We know that works. we're just going to ignore that. We want to focus on this one, which is our macro function build. So I'm going to get each of the fields. This is what we get from context. This is the value here, or class here, which we get from the Haxe macro package up here. This is what we need to import. Whenever you're doing anything in macro context, you absolutely have to wrap it around if macro, because if for whatever reason you actually decide you want to use any of this context, let's say if I decided, for example, I wanted to use C field in my client somewhere, I would need to wrap everything around here like that. And then what I can then do is inside of client context, I can in fact start using C field. So just to show you, I can say C field like that, field dots, since autocomplete isn't quite working yet, let's just double check. Field name, let's just say field name is equal to empty. Let's just do that for the time being. Oh, type not found C field. The point I'm trying to make is you should find it actually. It's outside the macro context, so we should be able to access it, which is a bit odd. I don't know why it's not finding it. Let's just double check something. It's all in the same folder, so it's weird that it's not picking it up. Still can't find it. Yeah. I know what I'm talking about. Basically, if you wanted to access something outside of macro context, you would obviously make sure to not wrap it within macro context, but considering that all of this is in macro context, we're not actually touching any of this outside the macro context, so that's fine. My point was, even though it didn't technically work, if you wanted to use something outside the macro context, you would of course make sure not to wrap it around this if macro compiler conditional. I'm not sure why that didn't work. It should have done, but whatever. So, moving on a step then, let's go back to here. So we've got our parser.build. What we want to do is we want to generate some static functions in here based on these DB fields, or form IDs basically is what we want, form ID. So let's go here, and I'm going to call this form ID for ID. In fact, because we're marking this hidden, we don't care about that. So we just want our form ID, username and hash. Okay. So what I want to do is be able to generate a function like this. So static function. So in this context here, we've got our user. So it would be user. We would create an underscore, and then we would get our elements. So user fill, I'll do. Probably not the best name in the world, but we'll call it that anyway. So in here, what I would do, we want to get the HTML.browser. So in here, we've got all of these fields, right? Now, if we want to fill the data, then firstly what we need to do is we need to actually obtain these values. So user underscore username or something like that. And that would be an element. And in fact, we can say it's an input element because we know it's going to be a text field. So we would have js.html.star. In fact, is browser inside of that context? I think it's in that context, actually, thinking about it. Well, let's double check. Let's double check. Where is it? Let's get rid of that. API documentation. So our browser is there. Okay. So yeah, I thought it might have been. So we import these two, and we'll have two different input elements here. And as you can see, I'm lowercasing it. So in here, I would say user underscore username, and I would cast. I'm casting here, and you'll see why in a minute. Browser dot document dot get element by ID. So this is how we would do it. Our ID we pass in to here form ID username, and we're casting it to an input element. The reason we do that is because the browser.document.get element by ID is returning us just an element, but we do know it's going to be an input element because that's what we will generate, or we would be using a template in this case, technically speaking. Same with user underscore password as well, so we would do the same there. Like that. So when we build that, it's going to be successful. This is what we get. We've got our user function here, user fill. We've got a couple more functions suddenly appeared, and it's become slightly bigger, surprisingly. But this is what we get. This is the results of our JavaScript file. It doesn't look like much, I know. Well, it looks like a lot considering what we've done in here. It's not much. Was what I was meant to get at there. But this is the kind of code that we want to generate from this parser.build. So let's go ahead and start doing that. So let's start by actually generating these two values here. So I'm going to wrap this around a comment block. So when we go ahead and build unknown identifier, that's fine. So when we go ahead and start doing this, we're going to in fact get those fields. So let's get our fields from our parser. Let's call them T fields like I did previously. Parser.fields, I believe, right there. So down here, I'm then going to start creating that field value, which is an input element. So what I'm going to do is create a new field. Now, if we go back to here and we go to haxe.macro.field. Where is it? There. We have these. So we've got a name, a position, and a kind. Now, obviously those are required. We will, in fact, be using access as well. So let's go ahead and start doing that. So name. Our name is going to be the name of the file. So first of all, we're going to get our parser.table name, and that's going to be 2 lowercase plus underscore plus and then the field. In fact, I need to iterate over that. tfields.length. Let's get our tfield. And in here I'm going to say .tf dot and then our field name, which I believe is just field name, like that. We need a kind, which is a field type. So our kind is going to be an fr. Because it's a variable. Inside of here, what we want to do is we want to create a complex type. Now, it wants a complex type, but the type that we want to get is not actually complex. Well, it sort of is, I suppose, in a way. But anyway, what we need to do is we need to consult our context class in order to get this context type, because what we need to do, let's go to our context class, where is it? Here we are. Okay. So if we go down here, we have a function called where is it? Here we are. ToComplexType. So we've got a ToComplexType that requires a type, and our type is well, basically what we want to do is just get the value, which we can get from also type of, strangely. I did do it a different way a while ago. Let me just consult my other projects a minute. 2 seconds. I remember doing this quite a while back. So this is what I did. That's the return value. So context.getType, and that was a string. So let's do it like that. So we'll do context.to complex type, and then we did what did I say? Context.getType. So if we go back to here, we're not going to use that type of, we're going to use getType. So our getType, what is that? That's a name. It resolves a type identified by name. So let's go back in here. I'm going to say context.getType, and we need the full path for this. js.html.input input element, sorry. We need to do it slightly differently. So I mean, for now, we know it's going to be input element, but in the future, we'll need to make this a bit more sort of future-proof. But for argument's sake, let's just make it input element. And then the last thing that we need, go back here, is the position. And that is quite simply just context.currentPos. We're going to add that field to here. And then, so if we go back here, remember we commented those two out. Those two are input elements. Let's now build it. Oh, interesting. Oh, what fields has it generated? It might not. We didn't do two lowercase, did we? And we also actually didn't use the option. Yes, so we technically, well, yeah. Let's do it this way. So we also didn't use the options. Let's go back to our parser. We need to be using options.get. Which would be this. No, it will be form ID. Like that. I'm just going to trace that just to make sure. Can I access username and static function? Okay, so now we've definitely generated the var. So as you can see, we've got our pack just HTML, which we get from here. I believe that's referring to the kind. Yes, it is indeed. So as you can see, cannot access user_username and static functions. So we are definitely creating the field correctly, but we did forget to put the access modifier on, which is in fact a static. We need to make sure we do that, otherwise we won't be able to access it. So it's generated those two fields correctly as expected. If we go here, we've got our HTML input element there, and we should, in theory, also have that somewhere as well. Oh, of course, it's JavaScript, it doesn't know. But yeah, anyway, so it is generating the those two fields, which is great. So we can get rid of that now. Next thing I want to do is actually generate this function. So let's call userFill. I'm just going to call it for the time being. That's obviously still working. So now what I'd like to do is comment this out and start getting this to work. So, of course, we have an error, and then identifier userFill. So let's go ahead and create this function then. So back into our parser. Outside of this, because this is in the scope of the actual file itself, we want to generate a function called user. fill. So this is going to be our fill function. Let's go to so yeah, it is still technically a field. I just thought about it actually. It is still technically a field, but in our field type, we're calling it a function. Okay, so this is our function here. So it wants arguments. We don't have any, so we're just going to leave that empty. Our expression is the function body itself. Now we can actually do that in a different way to what we were doing previously. And return function, we're not returning anything, so that can be null. So let's go ahead and create our function. Not here, here. So let's create our function. So we need args that can be empty. Our expression is a macro, so we're going to have our fill body, which is going to be a macro, and within this macro we're going to have our names. So this field name here, for example. So I think what I'm going to need to do is create an bunch of expressions. Okay, we'll do it this way. So what we need to do is generate expressions that match this. So what I'm going to do is this. Expressions, which is going to be an array. Inside of here, I'm going to say expressions dot push macro in here. I'm going to put I believe it's I. Let's just double check that note. I'm going to go to manual, macros, reification, expression reification. Okay. That's not what I'm looking for. Generates an identifier from the given string. So yes, I believe that's what I need. So in fact, we don't need that there. What we need is this. So so within here we want to get our parser.table name, lowercase. So let's just generate our name from here. So fname is going to be that. Fname fname. That's going to be equal to cast browser document get element by ID. So we've got our string here, but what we want to get is just this bit here. So I'm just going to get that, which is going to be F ID. Oops. FID. Ooh. I don't. It's wrapped in a string, so I don't know if that's going to. Do I need to escape that? Hang on a minute. Right. Yes. So that's the value that we want. Right. So we don't want to do that. We want to do this. And then we're going to cast it to our input element. So that's our macro expression. So when we go ahead and fill our body, we're just going to say $A, and then our expressions. In fact, do I need to do that, or do I not need to do that? So our expression in here is going to be filled body. Our return is null, I believe. Go back here. Args expression return null. Okay. So let's test that. Oh, interesting. And then identify our expression as I did something. It was meant to be that. And then identify user fill. That's because we didn't actually create the field. Of course we didn't. So we still need to create our fill field. I hope someone caught that. So in here, this is where we actually put our function inside the field. So let's go back to here. We're going to have our access modifiers, which is going to be a static. Our kind. And in this instance, our kind is going to be ffunc. We're going to pass in our fill function. Got our name and position. So our name is this. So var, let's say t TP name. So I'll just use that in place here. TP name plus underscore fill. And our pos is our context.current pos. Identify ffunc is not part of field type. Oh, okay. Field type. Right, okay. Okay, fair enough. And then identify user fill. Ooh, interesting. User underscore fill. Oh, of course, we need to actually add that field to fields. And there we go, it's building. Let's take a look at our JavaScript. So test data fill, we've got that in there. We've got a null value there because obviously we don't have this, but it's generating test data as well, and it's generating our user fill as well. So we know now that's working on both those files. So we're generating our test data and our user fill on both those files. Quite long-winded. We're getting up to 45 minutes, but maybe you've learned something. This is going to be an open source project eventually that will perhaps help you to build website applications using Haxe. My name has been Luke Selman, and thank you very much for watching. Goodbye.